Welcome to This Explainer. You know those action movies where the hero just grits their teeth, digs deep into some endless reserve of willpower, and somehow survives the absolute unsurvivable? Yeah, today we're completely dismantling that Hollywood myth. Instead, we're diving straight into the cold, hard science of human endurance under extreme restraint. We're going to look really closely at documented survival cases to understand what actually keeps the human machine running when literally everything around it goes critically wrong. Let's get right into it. So, what actually happens to the human body and mind when pushed to the absolute limit of physical torture and environmental isolation? Honestly, it's a fascinating and kind of terrifying reality to unpack. We're going to break down the body's defensive reactions to unimaginable extremes. Because here's the thing, when the human body is backed into a corner, we don't rely on cinematic bravery. No, we rely on a highly complex, cascading series of biological defenses.
Look, we've all been sold this idea that surviving an extreme scenario is just a matter of getting lucky or having sheer, unstoppable willpower. But the reality? It's a totally uncompromising equation. Survival is a strict calculation of physical constraints, biological realities, and spatial orientation. When we actually examine these documented cases, it turns out the survivors didn't just want it more. Actually, scratch that. They might have wanted it, but ultimately their bodies just mathematically aligned with the parameters of survival.
Section 1. Reframing Survival, Beyond Willpower and Luck.
Moving on to Section 2, Internal System Failure, specifically when the brain starves. Let's talk about cerebral hypoxia, which really shows us the stark biology of a starving brain. You see, the human brain is incredibly greedy. Despite its relatively small size, it demands this massive, uninterrupted flow of oxygen just to keep its own cells from literally destroying themselves. In extreme environments where that flow is restricted or cut off entirely, the biological timeline is just completely unforgiving. The brain doesn't just get tired, it becomes severely damaged because its cells are rapidly deprived of their essential fuel. When that oxygen is cut off, the clock doesn't just tick, it triggers a rapid, completely irreversible system failure.
All right, Section 3, Structural Trauma, the breaking point of bones.
Think of a fractured pelvis like this terrifying domino effect. Step 1 is the massive physical impact to the structure itself. Basically, a violent exertion of force against the body's foundational architecture. But the real danger? That's Step 2, profound systemic shock. Because your pelvis houses major blood vessels, a break there threatens catastrophic internal bleeding. Instantly, Step 3 kicks in. The body initiates extreme defensive biological reactions. It's frantically rerouting resources and spiking your blood pressure just trying to keep the lights on. It's an all-hands-on-deck emergency.
Which brings us to Section 4, Environmental Extremes, Skin Against Boiling Heat. Just think about the sheer speed of failure when our biological thresholds are crossed. Take water at exactly 160 degrees Fahrenheit. The tissue destruction at that temperature is incredibly swift and absolutely merciless. We're talking about milliseconds of contact before massive heat transfer begins. Within mere seconds, the cellular structure of your skin completely fails, compromising our body's primary barrier. And within minutes, massive systemic isolation and defensive reactions take over as the body realizes its walls have been breached. It just perfectly proves the terrifying, measurable contrast between intense environmental heat and human fragility. Okay, Section 5. The ultimate physical threat, surviving an atomic blast. 1.9 miles. Now, this isn't just some random estimate. It is a highly precise mathematical boundary for survival. Inside that radius, the thermal radiation and pressure wave simply erase human biological capacity. Period. There's no way around it. But outside that exact 1.9-mile line, survival suddenly becomes biologically possible. At the absolute edge of human endurance, staying alive isn't about grit or toughness, it is purely mathematical and entirely dependent on your spatial orientation relative to the physical threat. Literally, where you are standing changes the entire equation.
Let's wrap this up with Section 6, the final equation, the science of staying alive.
As we've seen documented across all these extreme cases, from the rapid cellular death of cerebral hypoxia and the systemic trauma of a crushed pelvis, to the immediate failure of skin at 160 degrees and the apocalyptic pressure of an atomic blast, enduring absolute destruction really relies solely on three cold, objective, scientific principles. First, it's a strict calculation of the physics acting upon you. Second, it's your precise spatial orientation to the danger. And third, it is the unyielding, completely inflexible biological limits of your body. That's the whole shebang. So, surviving the impossible isn't magic. It actually forces us to look at our daily lives entirely differently. I'll leave you with this thought. If enduring the greatest extremes known to humanity is really just a calculation of biology and physics, well, how well do you truly understand the physical limits of your everyday world? And when you really think about it, just how close are you to your own breaking point?